Hey, what's going on guys? Welcome to my basic statistics for beginners video. In this video, I will try to explain some of the basic things you have to know to get started with your data science journey using Python. The first thing that you have to do is to go to Kaggle, which is an online community of data scientists and machine learning practitioners. You will go ahead to find the Pokemon dataset, which includes the various attributes such as the name, types of the Pokemons. If you never heard of Kaggle before, I would definitely recommend you to go and check it out, because over the years they have updated and broadened their site to include almost everything a beginning data scientist could need. They have tutorials and basic classes on Python, and also some other competitions that you can join. They also have a host of data sets that you can use to host your data science skills. From here, go ahead and download the dataset. Okay, so once you have downloaded the dataset, you will go ahead and put the dataset into a directory which is more convenient for you. In this case, I will put it on my desktop. Next, you will go to your Jupyter notebook and create a new Python file and save it in the same directory as your dataset. Let us begin by importing the essential Python libraries. The first one that we have to import is Numpy. So we'll import Numpy as np. Next is Pandas, and we'll import it as, and import Seaborn as sp. Lastly, we will import, and you will go ahead and run this. So all these are actually libraries that you can import for this analysis. The first one, Numpy, is actually for numeric computations in Python. Pandas is more for data acquisition and preparation. Matplotlib is a low-level library for data visualization, while if you're more advanced, you can use Seaborn, which is a higher-level library. Oh, and don't forget to set the default Seaborn style for the graphics. Go ahead and run this. You can run each cell by clicking Ctrl and Enter. You can create another cell by pressing on Option and Enter for Mac users. Okay, the next thing that we have to do is to import the dataset into our Python folder. The dataset is in CSV format, hence we need to use the read CSV function. So I'll import the dataset and name it Pokemon data using the read CSV function to import the dataset. As you can see, I typed the exact name as the Pokemon dataset that you have imported, and go ahead to run it. You have imported the dataset, but now you don't see anything, so you have to go ahead and type this line over here. This allows you to take a quick look at the data using the head function. As you can see in the dataset over here, it just gave us a sneak peek of the first few lines of the dataset. So after importing the dataset, you will go ahead and check the vital statistics of the dataset using the type and shape attributes. So let me print out for you to see. And you will go ahead and run it. These two lines over here tells us some of the vital statistics of the dataset. The first one will be showing us the type. The type of the dataset that we have is a data frame. A data frame is a two-dimensional labeled data structure with columns of potentially different types. You can think of it as like a spreadsheet or SQL table or a dictionary or series objects. It is generally the most common used in Pandas object. Next, it will show us the shape of the dataset. The shape is a tuple that gives you an indication on the number of dimensions in the array. Next, we will check the variables and their types in the dataset. So we go ahead and print out the Pokemon data types. You use D types to print out the types of the Pokemons. As you can see, it will show the types of the various attributes in the dataset. After getting the vital statistics of the dataset, we will go ahead and start extracting variables from the dataset. We will start by analyzing a single variable from the dataset, HP. Extract only the HP attribute of the data. And you will go ahead and print out the data type. As the same as above, this will print out the type as well as the dimensions of the data. Also use the h function to take a quick look at the HP variable. Next up, we will go ahead and check the summary statistics of univariate series using the describe method. So hp.describe. As you can see, once I run the line over here, it will show me the summary statistics of the univariate variable, in this case HP. Show me the count, which is 800, the mean, standard deviation, minimum, as well as the quartile ranges, where it starts and ends, as well as the max value. We can further visualize this by using a box plot. So to plot a box plot, this is what you have to do. So in this case, you'll use Seaborn to plot out the box plot. Go ahead and run it. And you can see over here, this is the box plot of the HP variable. So what kind of information can you infer from this box plot? Okay, to start off, this is the minimum value of the variable, and this is the maximum value. You see this box in the middle? This is the interquartile range. It's the difference between the upper quartile as well as the lower quartile. The lower quartile in this case is the 25% mark, which is 50 over here, 50. And so this is just a range between the 25% and 75% in range. This is the median, which cuts the data set into half. So this side is one half of the sample, and this is the other half of the sample. We can further extend the summary to visualize the complete distribution of the series. And the first visualization is a simple histogram with automatic bin sizes. So we'll go ahead and use Seaborn to plot out the histogram. The purpose of a histogram is to graphically summarize the distribution of a univariate dataset. The histogram graphically shows the spread of the data, the skewness of the data, as well as the presence of any outliers. So the second visualization is a simple kernel density estimate. This technique is similar to the previous one, but this one allows you to create a smooth curve given a set of random data. As you can see, the kernel density estimate is basically a straight line version of the histogram. And of course, you can also plot out both the histogram and the kernel density on the same plot. And finally, let's go ahead and plot the violin plot. So let's go ahead and run this. And we have plotted out the violin plot. The violin plot basically combines the box plot, which is over here, as you can see, as well as the kernel density estimate. So this is a very useful thing that you can use. Now let's move on to bivariate statistics. We will start by extracting two variables and their associated data as a Pandas data frame. In this case, I'll use HP versus attack. Or HP equals. We will analyze the two variables from a data set. In this case, I will choose HP and attack. We can of course check the univariate summary statistics for each variable as well. So in this case, I will see the summary for HP. This is for HP as well as for attack. The next thing that you want to do is to visualize the univariate distributions of each variable independently first. Firstly, you have to set up the Matplotlib figure with 3 subplots. So this is what you have to do. And next, you will have to plot the basic univariate figures for HP. We'll use box plot. We'll use the box plot, kernel density estimate, as well as the violin plot for HP, and do the same for attack. And you will run all these lines over here. You get the various plots for the two different variables. However, it is more interesting to visualize them together in a joint plot. So in this case, you will use the Seaborn to do a joint plot. And here you have the joint plot for both HP and attack. The histogram on the top shows the distribution of the variable at the x-axis, and on the one on the right shows the distribution of the variable at the y-axis. The scatter plot right here shows the relationship between the x versus y variables, and it tells us something about the correlation between the two variables. But you can see the correlation between the two variables by joining them into a joint data frame. So this is what you will do. You will combine the two variables into a joint data frame. And you can see its correlation. When the variable correlates with itself, it will show a correlation of 1. So this is the value for the correlation between HP and attack. You could also visualize the correlation matrix as a heat map to gain a better insight. As you can see, you can also use Seaborn to plot a heat map. Similar as before, this value shows the correlation between the two variables. But what's better about a heat map is that you can see the extent of correlation just by looking at the color. To add text over the heat map, you can use the A0 attribute over here. If A0 is set to true, the text will be written on each cell. And lastly, we'll do the analysis for all the variables in the dataset together. We will analyze all the numeric values in the original dataset. The first thing they have to do is to extract only the numeric data variables. So you'll put the numeric variables into a separate data frame. In this case, I will separate the variables manually. And by looking at the dataset, these are the variables that I have identified as numeric. And I will see the vital statistics of all these variables. And yep, this table shows the vital statistics of all the variables that I need. Similarly as before, you will draw the box plots of all the variables. So in this case, all the box plots are placed into one figure, which is very useful. We will also want to draw the distributions of all the variables. So we will start with and instead of plotting all the figures one by one, it will be a wiser choice to use a for loop right here to minimize the number of codes that we have to use. So we'll set the counter as 0 and do the for loop. We'll use the for loop to print out the histogram, kernel density estimate, as well as the violin plot for all the variables. And to see the correlation between them, we will calculate the complete correlation matrix. Again, it is a better way to visualize this on a heat map. Just from this figure alone, I can see which variables are more correlated to one another than the rest. The much lighter ones, such as this, are the ones that have a higher correlation with one another. So in this case, special, defense, and defense attributes have a greater correlation than the rest of them. And lastly, we can use pair plots to draw pairs of variables against one another, as usual using Seaborn. At a glance, you can see the scatter plot between all the variables plotted against one another. And that's all for me today. I will be uploading more videos soon to show you all more advanced techniques that you can use for your data analysis.